Yeah, so I'm Arjun. I've been programming for a year. Um, I started programming for IOI, like that was my goal when I started. The goal was to give you all like a brief overview of how someone like me, like an intermediate level programmer, goes about solving a problem. So hopefully you guys can take away how you should start solving problems as well. I think most people have voted, so I'll just start with this. Most people have chosen Zetsia rectangle. Okay, we have a rectangular region that is 10 to the power 5 units along the x-axis and 500 units along the y-axis. We assume that zero zeros at the and the bottom right is at top left. Okay, yeah, fine. Right is okay, fine. Draw a rectangle with its base on the x-axis of maximum area within the region, such that it does not contain any of the endpoints in its interior. Okay.
Arjun, can you please share your full screen so that everyone can also see the question?
Okay, yeah, sure. Let me just see. Okay, can you guys see it now?
Yes.
Okay. There are 5 points. 1, 4, 2, 3, 3, 2, 5, 1. Okay, fine. So then, hmm. One second, I'm just trying to think. Is this better?
Yes.
Okay. Yeah, so you're basically given endpoints on the plane, and you have to make the largest rectangle possible such that it doesn't, that none of the endpoints are within the interior of the rectangle. So let me just start writing observation. So on the compiler window, I'm just writing some thoughts, they're not necessarily correct right now. I'll keep on refining them as I go. But yeah, sure. So I'm basically um okay. I'm trying to basically find some constraints in which we can make the rectangle, because right now, if I was to brute force check all rectangles, then it would take something like okay, one second. A brute force check of all rectangles would take around order of size of plane squared multiplied by n. So I'm just trying to find make an observation to reduce the number of rectangles to check. Now the first major observation is that so if we just have a rectangle.
Can you please explain the question once? Someone has asked in the chat.
Okay, so the
You don't
question
need to
basically.
write everything. Yeah, thanks.
Okay, I'll just write. Okay, the problem is basically this. So we're given
You
a,
don't need to write.
I'm just writing a condensed version.
Okay.
So we're given a plane of size 10,000 by 500, and in that we're given um, n points on the plane where n less than equal to 100,000, and we need to find a rectangle on the plane of largest area such that none of the endpoints lie inside the interior of the rectangle. We need to print the maximum area. Okay, is this clear? Okay. If you guys have a doubt, then you guys can just turn your mic on and ask. I prefer that because I can't see the chat window while I'm doing the code.
Okay, they will not be able to unmute. You'll have to open your chat and keep it at the side.
Okay, let me try to do that. Okay, fine, I can do it like this. Okay, so you want me to draw a diagram? Fine, I'll do that. I'll just connect my phone. Give me a second. Or I'll just use the whiteboard feature. Right? Share whiteboard. Okay, so you guys can see the whiteboard, right? Okay. So let's say you're given this plane. Okay, this is like a coordinate plane. And you're given endpoints on it. Okay, I'm not giving formal points with coordinate locations. I'm just marking some points to explain the problem to you. Then I'll give you a sample case. Okay, so you're given endpoints, whatever, and then you just have to make a rectangle such that none of the endpoints are within the area of the rectangle. So, for example, this would be a valid rectangle since none of the points are inside it, and this would be an invalid rectangle since the point in the top left corner is inside it. Now, since there are many such rectangles you can make that are valid, we need to make one with the maximum area. And in this one, it would probably be this rectangle. Okay. And points can lie on the boundary of the rectangle. That's not a problem. Okay, so that's the problem. We just need to print this maximum area that we can achieve by making rectangles. You guys wanted a sample test case, so I'll just give you the one in the problem statement itself. Okay. So the case is, so for example, if there are 5 points, let me just mark them on the whiteboard while I'm reading it. Let me start a new one. Okay. So if you're given a rectangle with 5 points, the first point is 1, 4. The second point is 2, 3. The third point is 3, 2. The fourth point is 5, 1. And the fifth point is 5, 2. Then we need to find the largest rectangle we can make such that none of these 5 points are included within its area. So then the rectangle whose bottom left and top right corners are 0, 0 and 2, 3 is, for example, one example of a valid rectangle. Another possibility is the one with top right corner at 3, 0. Sorry, yeah, with 3 at 3, 0. And 5,000. Yeah, fine. Let me just find the largest rectangle. Yeah, the largest one that meets the requirement is the one with the bottom left corner at 5, 0. So at this point, the bottom left one, and the topmost corner here which is at 500 and 10 to the power 5, right? So the largest rectangle we can make is this one, and we need to print the area of this rectangle, and its area is given here. Okay, is the problem clear? Sorry, let me just open the chat. Okay, the problem's clear, right? I'll just move on to solving it then. So a few observations are that um, if we have a random valid rectangle, then we should move its left boundary as far left as possible until it touches a point. Okay, we should do the same for the right boundary. Now, what this basically means is that um, how should I explain this? So for any rectangle, if I'll just explain on the whiteboard again, but basically if the rectangle is stopping at a random point, for example, if these are your points, then if the rectangle is like this, then it's obviously suboptimal because you can keep on expanding the right boundary and you can keep on expanding the left boundary, and the same for above and below, right? So it's, in order to make it optimal, we should expand the boundary until it reaches points at all four boundaries, right? So it's something like this, the optimal rectangle around this. So I guess if you store, let me just share my code now. You guys can stop me if you have any doubt with what I'm saying. Okay, I'm erasing this. If you fix any point as the left boundary pivot, then as you expand the boundary right, the height of the rectangle will keep decreasing because the upper and lower boundaries are bounded by the heights of the points, left bottom or left top, meaning which left, I'm saying that like not the corner, I'm saying the edge of the rectangle, the left edge of the rectangle, right? So as we keep on expanding so let's say we fix a point that lies on the left edge of the rectangle, then we keep on moving the right edge to the right. Okay, if we encounter a point in the middle, we need to increase the height of the lower edge so that it does not intersect with the point, right? Now we need to find an optimal point in this. Now what we can do is, let me just see the constraints. Okay, the height is 500, so that's useful. Okay, so the constraints are 100,000. 100,000 into 500 is 10 to the power 7, which might pass. So the expected complexity is probably 500 into n. Okay. Okay, so I'm not using a brute force approach. I'm just trying to break down the problem a little bit, like keep on optimizing it. And yeah, we can take the right boundary also. I'm just taking the left edge example, but it would work if you took the right boundary and moved the left edge also. Yeah, sorry. So the case, I'm sorry, I didn't realize this earlier. Another part of the question is that the base has to be on x-axis, which simplifies the problem a lot. So let me just share the whiteboard again. The whiteboard. Okay. Yeah. So I'm just erasing this. Clear all drawings. Okay. So let's say in this point, on this plane, we have 3 points. Okay. Now we need a rectangle with the base on the x-axis and maximum area. So my logic so far, what I've figured out is what we can do is, let's say we have 4 points actually. So take any one point, okay? Let's say we take this point, okay? So then we take this point as the top edge of the rectangle, okay? So the rectangle's top edge lies on this point, that's determined. Now for each point, we need to find the first point on the right such that if we were to extend the wall beyond that point, so let's say we need to make the right edge, right? Now, if we were to extend it further, then this point would lie in the interior of the rectangle. So let's call this point as the right bounding point, okay? Or just for short, let's call it point RB, okay? And if you guys have observed this, then RB is just the first point such that the x coordinate of point RB is less than the y coordinate of point RB is less than the y coordinate of our pivot, right? You guys can write in the chat if you didn't get that. Okay, I'll assume that's clear. Then you have to do the same for the left. You have to find point LB such that its y is less than the pivot y and its x coordinate is less than that of the pivot. So this is the left binding point. So our optimal rectangle with this as the pivot would be these two. Now there is this one edge case where, for example, we have the leftmost point and we want to make the rectangle such that its base is the x-axis and it doesn't have a top binding point. Its binding point is just the plane as a whole. So for that, we can just manually check the left. I'm sorry, Siddhant is saying something. We select the points in all directions, which is at farthest distance from opposite sides of the plane, and then take an intersection of those lines. Could you explain that slightly more, Siddhant? I'm not getting your logic.
Yes, Siddhant, you can speak.
Siddhant, you there? Pallavi, can you hear him? I can't hear him yet. Okay. Then Siddhant, can you just explain on chat what you meant?
Hello, am I audible?
Yeah, you're audible.
Yeah, like suppose I was telling that we choose the point in such a way that which is at the farther distance from the opposite side of the plane.
Opposite side of the plane means what? Opposite to what?
Like suppose one point is located at the topmost of the plane, and
Okay.
then from the bottommost side of the plane.
Yeah.
So if we select the farthest point, like from the bottommost side of the plane, we select the point which is at the largest distance.
Okay, so you're saying something like this. I'll just clear this and try to understand. So you're saying, for example, we select the topmost point.
Yeah, suppose this point is on the plane. Yeah, and from this line, yeah, the bottommost line.
Okay, then you want to select the bottommost point as well. And then
Yeah, like maybe the points may be scattered anywhere. So from the opposite base, like suppose the largest y-axis distance and the largest x-axis distance.
okay, I get it. So you want to after you selected a point, you want to select a point which is at largest distance from that point.
Not maybe from that point, maybe from the x-axis and the y-axis.
Okay, from the x-axis and the y-axis. So can you explain a little more? So once you selected this pivot, what's the function of this point that you selected initially?
Sorry?
What's the function of this first point that you've selected?
No, if I get all the points in all the directions, like 4 points in all the direction, I will get the
Okay.
rectangle with the maximum area, like which would not include
Okay.
any
Got
point.
it. So you mean select a random point and then select the first one in each direction?
Yeah, like suppose we select 4 points in all directions at maximum distance from the x-axis and y-axis.
At maximum distance from the x-axis. Okay, so first of all, the rectangle has to be like the base of the rectangle has to lie on the x-axis.
Yeah, base has to lie on the x-axis.
So you're saying we should pick the points that are as far apart as possible.
Yes.
And then make the rectangle around them.
Yeah, we can do that.
Okay, so a few things. So what would you do in a case like this? Just help you understand this. So let's say there are 5 points. There's point this, and this. Okay, so what would you do in this case?
No, suppose like in this case, what will I do? From the top side of the plane,
Yeah.
I will choose the point which is at the largest distance from the top side of the plane.
So point number 1.
Point number 1, correct.
Okay.
And
Then
from the left hand side, that is the y-axis.
Yeah.
The point is 5. Point number 5 is at the largest distance.
Okay.
And same way from the other way around, like from the bottommost is the 3rd or the 4th point.
Okay, so the 4th point, that's it.
Yeah.
So but
we can, yeah.
But if you want to make the rectangle with these points as the bounds, right?
Yeah, if we can make so. Like.
But if you do it like that, then you see that point 2 is in the middle, right?
Yeah, that is there. Yeah.
Okay, so we just need to guarantee that no points are in the middle.
Okay.
Then Aman, we take all points one at a time and make 2 lines, horizontal and vertical, and cross the point. Now we have 4 rectangles with point as origin. Okay. Now we check if any point is present inside any quadrant. If it is present, then the quadrant we don't take that into account. And now we get the max rectangle for this point, repeat for all points and give the answer. Aman, can you just speak once and explain what you mean?
I meant like it's supposed like 0.3, right?
Okay, sorry, let me just undo that.
Yes, we'll just keep it here itself.
Yeah,
so
0.3.
0.3, like I crossed one line horizontal and one line vertical from 0.3.
Okay, so you mean like one line horizontal, vertical, one line horizontal. Okay.
Yeah, now we can check using the coordinates whether any point is there in, like suppose now it's into 4 parts, right?
Yeah.
So we can check, okay, over here 2 and 5 is there in this quadrant, and 1 is there in another quadrant. Now we have like two quadrants on the top of 3 and 4, right?
Yeah.
So these two quadrants, we can see which has the maximum area. So now for this point number 3, we have got the maximum possible rectangle, right?
Okay. Fine.
Yeah, this 3, 4, 500, the top one.
3,
Yeah,
4,
top
5
right
and
hand.
this one.
Yeah. No, the entire one, right? It will go to the entire one. We are not stopping at 4. We are going entirely till the.
Okay, till the end, fine.
Yeah.
But keep in mind that the rectangle has to have the base at the x-axis.
Okay. So no, actually, I was just wondering before this. We're thinking like, okay, not an issue. For that also, I guess we just have to take the points considering the base. So over here, since the rectangle which already has points where when the base is there, right? This 2 and 5 is already there, right?
Yeah.
So
Okay.
in this we can say that no possible rectangle will be there with the point 3, right? So we can continue that with 2, 5, 4, something similar like that along those lines.
So I mean, your logic is that we extend it like this.
Yeah, we extend it from one plane to the the
Okay.
entire, yeah.
And then
We
if
check if any point is present or not.
okay, that's interesting. But what if the optimal? Let me just clear this.
Yeah.
So let's say it's like it's something like this, okay?
Yeah.
So you check this. Let's say the points are 1, 2, and 3.
Yeah. So first we make a line through 1, horizontal and completely till the end.
Okay.
Okay. Now we check. Is there any point in 1 which has the maximum possible area right now? So 0 to 1 is possible right now because the other one 2 is there, right? So we find we keep this, we save this, that this is the possible. Currently, this is the largest one, right?
Yeah. Oh, 1 second. Yeah, Siddhant, the base of the rectangle should be on the x-axis. Yeah. Anyways, go on, Aman.
Yeah. So currently, this 0, 1, this will be the largest one currently possible for this point.
Okay.
Now we repeat this for 2.
For 2, fine.
Right.
Yeah.
For 2, if we see the largest possible one, we can say that it is the entire thing.
The entire thing, fine.
Right, base on entire thing. And
Yeah.
for 3, if we do that,
yeah, for 3, if we do it, it
will be either the the right hand side extreme from the top to the bottom, right?
Okay, but
from the top to the bottom.
Yeah, but I would tell you that in this, the optimal rectangle would be between 1 and 2.
Okay.
So I think the issue with your logic is that you're checking for all rectangles such that 3 sides are bounded by the boundaries of the plane itself.
Okay.
And only one side is bounded by a point, right?
Yeah.
Now, the issue is that there would be many rectangles such that 3 points are bounded by a point and only 1 point, which is the bottom axis, is bounded by the plane. Right?
Okay. Yeah.
So it would not be able to check for that is the only issue.
Okay.
Okay. So that clear?
Yeah. Thank you.
Okay. Great. So does anybody else have a different logic to share, or should I move on to coding this? Okay, Sahil Sawani, can we use the largest rectangle in a histogram? Okay, again, Sahil, you can unmute yourself. Sahil? Okay, so I guess he needs to set up anything, but until then, I'll just explain what I was saying. So my point was that we fix any point as a pivot, and then what our algorithm needs to do is, okay, Sahil, I'll just address your thing in a second. But what our algorithm needs to do is find the first point on the right such that it's y, okay, right bound, oh god, yeah, right bound dot y is less than the pivot y, okay? So we need to find this point as a right bound. Then we need to find a point on the left such that left bound dot y is less than p dot y. Okay. So now what I would do for this, the algorithm for this is sort of a standard algorithm. It's done using a stack. Okay, so do you guys know what a stack is? If anybody doesn't know, then I can explain it. What a stack is. Okay, Siddhant, so the pivot point, it's not being selected on any basis. So we'll have to do this for all points. We'll have to select each point as a pivot and try this. Okay. So everybody knows what a stack is. So then I'll just explain how this algorithm works. Okay. So how this algorithm works is, let me break down the problem first. So let's sort the points according to their x coordinate. Okay. So the points are sorted from left to right. Is that clear? Okay. So then, like I said, we need to find RB and LB. Now RB is the first point for, okay, for each I as the pivot, RB, okay, Vishal, we're doing ZCO rectangles. So you can see it from the contest. I'll just put the link in the chat, 1 second. Oh, come on. Give me a second, please.
Arden, I've done that. You may continue.
Okay, thanks. Yeah, so for each I as the pivot, let me just undo this. For each I as the pivot, RB is the first point J such that J is greater than I and point J dot Y is less than point I dot Y. Okay. So this is the first question, Bharat. It's like, okay, so now for each I, we need to find the appropriate J. This is done through a stack algorithm. So what it is, we create a stack such that the element on top is, we need to find the first one such that the y is smaller than it. Okay, yeah, so the element on top is largest. Okay, and we iterate from left to right. Now as soon as we find an element that's smaller than the one on the top, we start popping elements from the stack. Okay, let me just, I think this will be clearer in code, so let me just start coding. Yeah, can everybody see my ID? Okay.
It'd be good if you can increase the font size a bit.
Okay. Is this better?
Yeah, thanks.
Okay, no problem. So let me just open the input format. Okay, fine. So there's an int n and then there are points. Okay. So I'm just taking input of the points. Okay. Now we need to sort the points according to the x-axis, according to the x coordinate. So I'm just sorting it like this. Sort x plus n. I'm sorry, arr plus n, right? Now we need to create a stack with pair intent. Okay. So this is how we this is how the algorithm works. Okay. So for the stack, for each point, while the stack is not empty, and the top element in the stack is larger than the element we're trying to push. So it's larger than array I dot second dot first. Okay. We okay, we pop the element from the stack, and you guys can observe this. Every time we pop an element from the stack, it means that we found the first element on the right, which is smaller than that element. Okay. So every time we pop an element, we do rb element dot second is equal to I. Okay. And over here, we can say after we popped all the elements, we have to st dot push make pair ari dot second and I. Okay. So we found all the right bounds. Now we'll just do the same for the left bounds. And okay, so here's an idea. Instead of making it I, we can just store the coordinate of the wall. So it will be the x coordinate. So it should be arri dot first. Okay. Now the stack is not necessarily empty right now. All of the elements that are still inside the stack are not bounded by a point. They are bounded by the plane. Okay. So what we do is while stack is not empty, we'll do pair int element is equal to st dot top, st dot pop, and the right bound of this element is equal to the right wall of the plane, which is 100,000, right? Okay. And now we need to do this exact same for the left one. So I'm just going to copy paste it. If you guys want me to write it again, I can. So let me just see the chat. Line 30 n is undefined. Yeah, good catch. Okay, Sachin. So the reason we're using the stack is because I mean the entire algorithm is based on stack only. So the top of the stack basically just stores. The stack is sorted in descending order, with the top element of the stack being the largest. Okay. And now every time we need to push an element in the stack, we need to make sure that this property is maintained. Therefore, if the element on top of the stack is bigger than the element that we're pushing, it means that this property will be violated, right? So in order to make sure this doesn't happen, we have to keep on popping elements from the stack. Now, every time we pop an element, it means that we found the first element to the right, where the y index is smaller than the current y. So that's the logic. If you guys are still unclear, I can try to explain it more, or if you want, I can send a resource where you can learn this algorithm. Okay. Okay, I'll send a resource. 1 second. Pallavi, it's not letting me share the link with everybody in the meeting. It's just saying everyone in the meeting room is the only option.
Wait, from the drop down, you need to select everyone. You'll have two options in two.
Okay, yeah, got it. Yeah, okay, so I've shared a resource where you can learn this algorithm. You can just try to learn it after the session. Okay, but the basic logic is that it finds the first element in the array to the left or right, which is smaller than that element. Okay, so I'm just repeating the same thing for from the other side. Okay, so now for each element we have found the left bound and the right bound. So now we're just going to compute the answer. Now the left wall is going to be the left bound of that element. The right wall is going to be the right bound for that element, and the height is going to be the height of the element itself. Okay, so answer is equal to maximum answer and height into width, right? So now we just output the answer, and I'm going to try this on a sample case now. Let me just check the chat. Sachin, were you not there earlier? Because I already spent quite a bit of time drawing the figure and stuff. Palvi, should I repeat it? Because I think you can just see it in the YouTube chat again. Otherwise, we've only gotten through one problem so far. Hello?
Yeah. He can. We have asked him to check the recording. No problem. Yeah.
Okay.
Continue.
So I'm just testing it with the sample case now. And it's giving the wrong answer. Okay, so I'm going to try to debug this. So for each point, I'm going to print the point coordinates, and I'm going to print what it found as the left bound and the right bound. Okay. Oh, I'm sorry. I got my mistake. Okay, so for the 0.14, okay, I'm going to make the diagram for this so you guys can see it. New share whiteboard. Okay. So this is 0.14. Then 0.23. Then 0.32. Point 0.51 and 0.5. I'm sorry, 51 and 52. Okay, so let's just review where we went wrong. Hmm. Okay, so I think the mistake in my logic was that I didn't consider the top wall to be a point, and I should have. So how do we do this? If the top one is a point, then mm, so basically between consecutive points, I should consider that there's a wall between. Fine, I got it. So basically, the problem was that we kept on taking the pivot as the top. Kept on taking a point as the top pivot, and while that's right, there's an edge case where the top edge of the rectangle lies on the wall of the plane itself. So in order to do that, we'll just have to check between consecutive points. Oh, somebody's scribbling on the. Oh, to see the chat. Okay. Oh, Ashutosh, like whatever. So I'll just finish coding it. Wait. I'm just sharing my code now. Okay.
Adam, can you please explain also what you're doing?
I'm just implementing what I just explained on the whiteboard.
Yeah, so if you could also explain the code once, it'll be good.
Okay, sure. Give me a second. So what I'm doing over here, distance is just the distance between consecutive elements, and now I'm just taking the max of the area with the top edge as the top of the plane, height 500, and the width as the distance between the points. Okay. And now this final one is just uh, the distance between the right edge of the plane and the last point. Okay, into 500. It should be fine. Yeah, that's the right output. So I'm just commenting the debug statements. Okay, yeah, this is giving the right output, so I'm submitting it. Okay, I've submitted it. Until then, I'm opening the poll again, so you guys can choose on what the next problem you want to do. Yeah, I've reopened the poll, so you guys can vote. Who voted for rectangle? I just did that.
Maybe someone who joined late.
Okay.
Yeah.
Okay, so you guys want me to do?
Okay, let's submit till then. They can vote till then.
Yeah, I submitted.
Yeah.
Yeah, I got a correct answer. Sure, you guys can see this. Um, so you can. Do you guys want me to run over the code once more? Or do you guys just want me to jump to the next problem? I thought I'll just go to the next one because we're kind of running out of time as well. Okay, fine. Summary. Okay, I'll give the summary then. Um, yeah. So I'll just do it quickly, sort of quickly. So over here, I just took input of n and the points. Okay. Then over here, I sorted according to the x coordinate. Okay, so points are sorted from left to right. Fine. Then in this, then this algorithm just found the left bound for each point I, where I is the pivot. Okay. I've attached the algorithm to do this in the link below, in the link in the chat. Sorry. Then over here we found the right bound for each point I, where I is the pivot. Okay. And over here, using the left bound, right bound to get the left and right points of the rectangle, we found max area. And now this was the edge case where the top of the rectangle is the plane itself. So we just found the distance between adjacent points and took the height to be the height of the plane itself. And that's how we found the max area. And over here, we just outputted the answer. Okay. Uh, I'll save this code right now and I'll upload it somewhere at the end of the session. Cool. Okay. Okay, now I'll move on to the next problem. Let me just see the poll results. Okay, so 4 people voted for penalty shootout 2. So I'll do that first.
Else, people, can you help break the tie between the votes, so that will help pick the question accordingly?
Yeah, there are 4 questions
with 4 votes.
Yeah, and I think I'll ignore the ZCO problems right now because I've already solved all of them. So you won't really get the experience of solving for the first time.
Okay.
So wormholes I'll ignore. So you guys just choose between chef and Q, not all flavors, and penalty shootout. I can just run over all of them. I think 3 problems I'll try to do in like half an hour, 40 minutes.
Okay, so let's start with penalty shootout then.
Okay, I'll start with penalty shootout then. Let me share my screen. Okay, so the week 2 of the DSA Learning Series and penalty shootout. Yeah. So teams A and B are having a penalty shootout to decide the winner of the football match. Each team gets to take a shot n times, and the team with the highest number of scored goals at the end wins. If the number of goals scored during the shootout by each team turns out to be the same, even after all 2n shots, then they stop and agree that the result is a draw. The 2 teams take shots alternately. Team A shoots first, then Team B shoots, then Team A, so on and so forth, until Team B takes its shot. Even though all 2n shots are taken, the result of the shootout is often known earlier. Okay. For each shot, you know whether the shot was a goal or a miss. You need to find the earliest moment where the winner is known. Okay, fine. So this is quite basic. So I'll just run it right into the compiler and explain the logic. Right. So in football, we know the result of a penalty shootout before it ends. If we know the result, if and only if, even if a team one scores all of their remaining goals, they will their score will be less than the current be strictly less than the current score of team 2. Okay, is that clear? Because this basically, in simple terms, it just means that, like, even if team 1 scores every goal and team 2 misses every goal, the verdict of the game can't, the verdict of the penalty shootout can't change. So we can basically, we can end the game right now only because we know who's going to win. Yeah, the remaining, yeah, that's right, Sachin. So what do we need to output? The smallest s such that after s shots, the result of the shootout is known. Okay, so I think I'll just code this. If anybody has a doubt with this, they can just put it in the chat right now, but I think this is pretty clear. Okay, so I'm taking input for the test cases. Uh, Taking input for the number of shots and the string. Okay, now int current score of two teams, we'll initialize it to 0, 0, right? And the remaining. Okay, this will just make our work easier later. So this array remaining just stores that you can do the, yeah, right, sorry. Okay, so this array just stores number of shots remaining for each team, team 0 and team 1, and this stores number of shots already scored for each team, right? Now we can just go through the string. Okay, Shlok while t minus minus. I'll just condense this, it's not really important. Okay. It's the same thing. Okay? Can we do something like decreasing the player one score to even negative side and then putting conditions on it? Rakesh, you can maybe unmute yourself for a second to explain what you mean.
Hello.
Yeah, I can hear you. Go ahead.
Yeah, so whenever A loses the match, so the A's score remains constant and B's score increases. So can we do something like not considering B's score and only decreasing
Yes.
player
Yes.
one's
Yes.
score?
You're right. You're right.
So kindly discuss that thing, how it can be
Okay,
done.
so I'll just explain once like this because I think this is easier to understand, and then I'll sort of redo it with your method. Okay.
Okay, yeah, thanks.
Okay. And no Shlok, this is a 1D array only. Like this is an current score is an array of size 2 and rem is also an array of size 2 only. Okay, so the current team is equal to I mod 2. Okay, now as Sachin pointed out earlier, we know the we already know the verdict if the remaining shots is less than the difference score difference. Okay, so if a current score of the current, so let's just find the difference first. Int difference is equal to current score of the current team minus current score of the current team Zor1. Okay. Zor1 just changes 1 to 0 and 0 to 1. Why remaining shots is less than score difference? Okay, Ashutosh had discussed this like right in the beginning, but basically the logic is that we already know the verdict. If like one of the teams can score all of their goals and the other team can miss all of the goals, and even then the first team will win, right? So the logic behind that is if their current score difference is greater than the number of shots the losing team has left, then the losing team can't cover the score difference, right? So in that sense, we already know the result. That's the only logic. Okay. So and so the differences I've just found, and int remaining shots is equal to rem of current team zor1. So if the difference is greater than remaining shots, then answer is equal to I plus 1 and we can exit it. Okay. And after each one, we do remaining of current team minus minus. Okay, Ashutosh, so Zor1 basically just changes. Okay. 0 Zor1 is equal to 1 and 1 Zor1 is equal to 0. So it just changes 1 to 0 and 0 to 1. Okay. So after we've done this, we just output the answer. I'll try to run it on a test case. And 4.6 is the correct answer, so I'm submitting it. Zoom the code a bit, okay? Is this fine? Okay. If anybody didn't understand the code, you can ask in the comment section. Okay, so this got wrong answer for some reason. So let me just recheck. Hmm. Yeah. Good one. My bad. Let me just recheck the test case again. Hmm. Okay, so we should check this for both, right? Yeah, I know that it's the absolute of difference, but the remaining shots will change depending on who we're considering to be the loser, right? Hmm. Okay. It's giving the correct output, so I'm submitting it. Who's drawing on the screen?
Please don't annotate whomsoever is doing it.
Yeah, so it gave the correct answer. Okay, so I'll move on to the next problem now. So I'm relaunching the. Okay, we already had some ties, so I'm going to go over them only. So the next one was not all flavors. Palvi, is there any way to remove this thing on the screen?
Yeah, just a second.
Okay. Okay. Also, you guys can feel free to ask any questions if you had any doubts with the previous problem. Okay, can I explain the logic once again? Okay, so Siddhant, the logic was basically that we just need to find the first point where, okay, let me just put it at when the meeting. Okay, um, so we just need to find the first point, Siddhant, where
Arun, you need to share your screen.
Sachin wants to say something. Okay, I'll share my screen in a second. Okay, so you guys can see my screen, right?
Yeah.
Yes.
Okay, so wait, maybe this is simpler. You guys are all you guys see cricket, right? Guys?
Hello?
Yeah, Sachin, what were you saying?
Sir, in previous question, in rectangle,
Rectangle. Okay.
if we didn't have that boundation of x-axis,
We'll
like
discuss rectangle later. Let's complete this first.
okay.
Okay. So the logic for this problem, I'm just explaining one last time. So the logic for this problem is basically we need to find the first point where loser cannot catch up. Okay. So for example, if how should I say, if team one has scored the first two shots, team two has missed the first two shots. Okay, then okay, let's say it's 3-3. Okay, team one has scored the first three shots and team two has missed the first two shots. Okay, now team two needs to score all three remaining shots to win the shootout, right? Considering n is equal to 5. Okay, but if team 2 misses its third shot, then we know team 1 has won the shootout because score of team 1 minus score of team 2 is strictly greater than remaining shots of team 2. Okay, that's basically the logic. So we just need to find the first point where this condition is true. Is that clear? Who was asking? Siddhant. Yeah, okay. Fine. So then I'll move on to not all flavors. Okay. Let me just share my screen. Okay, it's sharing. So in not all flavors, chef made n pieces of cake numbered from 1 to n and arranged them in a row in this order. There are k possible types of flavors numbered 1 through k. For each valid I, the ith piece of cake has flavor AI. Chef wants to select a contiguous segment of the pieces of cake such that there is at least one flavor which does not occur in the segment. So there are at most k minus 1 flavors. So find the maximum possible length of such a subsegment of cakes. Okay, fine. So this is also kind of a standard technique. So do you guys know what two pointers are? Okay, so this is a little kind of a variation of the two-pointer technique. So I'll just write the logic. Okay, it's fine if you don't know it. I'll explain from the beginning anyways. So we consider each range LR, okay? This range is valid if and only if number of distinct flavors is less than equal to k minus 1, okay? We need to find the range where r minus l plus 1 is maximum, okay, which is the size of the range. And we just need to print the size of the range, okay? So this is the basic technique. How we do it is we start with L is equal to 0, R is equal to 0. Then we keep expanding R while the flavors, okay, wait. While the number of distinct flavors is strictly less than K, okay? It's clear so far? Okay. Then we stop when the number of distinct flavors is equal to K. Now what we found? We have found the maximum range starting at point L, the maximum valid range starting at point L, right? Now we need to find the next valid range. Now keep in mind that there could also be a valid range like this, L plus 1 or minus 1 type, okay? But we don't consider this range because we know that range LR is bigger. Okay, so what we need to do is we fix R and increase L until the number of distinct flavors is less than K. Keep taking max of range. Okay, and then we'll keep on repeating this process until L is equal to n minus 1 or something. Is that clear? Or we can find a break condition later. But is this logic so far clear? You guys can comment. I'm audible, right? Okay, so the logic is clear. Then I'll just tell you how to implement this. Okay, so we first input n and k. So we input ARRI. Now this variable is going to store the number of distinct flavors in the range. Okay. This is the left pointer. This is the right pointer. Line 19, please explain again. Okay. So basically, let me just show you. Okay. Let's say this is our array and k is equal to 2. Okay. So now initially we start with L is equal to 0, R is equal to 0, and we keep expanding R until k is equal to 2. So you can just see like this point would be r is equal to, right? Now we do line 19. Line 19 increases L until the distinct flavors are less than K again. So now how this would work is we would increase L to 0.2 as well. So now the number of distinct flavors is equal to 1, right? Only 2. That's the logic. And then we start expanding R again. We expand R until point number 3, until point number 4, sorry. And then we repeat this entire process. Maybe it'll be more clear in code, I guess. Okay, no problem. So now this array just stores the frequency of each flavor in the range. And I'll just initialize it all to 0. Let me just see constraints on, okay, fine. We initialize it all to 0. And then flav f array 0 is equal to 1. So I'll find the break condition later. I'm not sure what it would be right now. But okay, what should we do right now? While the distinct flavors are less than K, and R is less than N. No, you know what? We shouldn't do this. This will mess up our implementation. Okay. So first, we should include the flavor that's at the current R. So if flavor frequency of array R is equal to 0, then distinct flavor plus plus and flavor array R also plus plus, and then R plus plus. Okay. So we expanded the R pointer as far as possible. Now we need to expand the left pointer. Okay, I found the thing, by the way. Now we need to expand the left pointer. Sachin, it'll be better to use set. Okay, I'm not sure how you would use set for this. Sachin, you can't use a set for this because set won't be able to keep track of the frequency of each color. But anyways, map can be used. Yeah, you can use map. I'm just using an array for this because K is small. And map is part of STL, which is not part of this week's course. Okay. Give me a second. I'm just thinking how we would implement this. So every time we expand an R, we should try to include it. Okay, so what we can do is if the distinct flavors are less than K right now, then max range to max range R minus L plus 1. Okay, fine. Now um, if r is equal to n minus 1, then we can break. Else, it means that, um, sorry, if r is equal to n, we can break. Otherwise, we should try to push up the L. So while L is less than equal to R and the number of distinct flavors is equal to K, if flavor of ARRL, flavor frequency of ARRL is equal to 1, then distinct flavor minus minus. This basically just means that if there's only one frequency of this flavor left, then removing it will remove this flavor completely from the set. So we're decrementing the number of distinct flavors. Flavor frequency of array L minus minus. Right? And L plus plus. Okay. Fine. So I think this is valid. The purpose of second while loop, Rakesh, is carrying out a line number 19 in the explanation. Okay, because right now, after we've completely increased R, we have basically just found an invalid range where there are K distinct flavors, okay? And so now decreasing R would be, we would just be going back on what we already did. So now we are increasing the L pointer until we find a range where there are less than K flavors. Does that make sense? But what I've done here is not right. Mm. And this should be equal to 1. Okay, so while plus plus R is less than N and distinct flavors are less than K, then okay, looks good. So I'm gonna try to run this. So 12 and 4, that's clearly wrong. Um, that's fine. We'll just try to output this. Let's try to just start with the first test case. Okay, so 0 0, then 1 0, fine. Why didn't it include 2 0? It's odd. Okay. This is my mistake. I shouldn't have done this. Okay, yeah, this is the answer. And what about 4 3? Hmm. I'm just debugging the problem right now. Okay, yeah, 3-0, fine. Should be 2. I would shift up to 3-3. But why not 4? Why didn't it consider 4-3 as the question? It's odd. Okay. Yeah, this looks fine. I'm just testing the second case as well. Yeah. So I'm just going to submit this and try. You guys got what I've been doing, right? Sachin, we're decreasing the flavor value on line number 50. Yeah, so this got correct answer. Do you guys want me to do another problem or do you want to wrap this up? Palvi, what do you think?
We can just relaunch the polling and ask people.
Okay, sure. So it's in progress. You guys can select which problem you want to do. Okay, so chefs in queue seems to be the popular one. Yeah, chefs in queue seems popular. But I'll wait for voting to finish.
Okay, then we can pick the chefs in queue and.
Okay. Sure, sure. Okay, so all the chefs except the head chef are standing in the queue to submit their bills. The chefs have different seniority. In all, there are n chefs of k different seniority levels. These are given to you in an array where A1, A2, AN denote the seniority of chefs in the queue. AN denotes the front of the queue, and A1 denotes the end of the queue. Head chef gets an interesting thought past his head. He begins to think, what if every chef starting from the end of the queue begins to delegate his job of submitting bills to a chef least ahead of him in the queue but junior to him. So the first chef ahead in the queue, which has the less value. The head chef's fearfulness of this scenario is F is equal to I2 minus I1 plus 1, where I1 is the index of the chef in queue, I2 is the index of the junior. So basically the difference in indices of the junior chef and the senior chef. Head chef's total fearfulness of chaos is the product of all fearfulness. Okay. If a chef has no junior ahead of him or her in the queue, then head chef fearfulness for this chef is 1. So you need to find the fearfulness of the arrangement modulo 1 in enter 7. Okay, fine. So this is basically just the exact same algorithm that we use for rectangle. I've put it in the Zoom chat. I'll just put it again. Yeah. So it's just a very standard stack algorithm. I'll put it in the chat. I'll code it in right now for this problem anyways. But the logic is this. For each index I, find the first index j where j is greater than I and arj is less than ari. Okay. If no such j exists, ignore that I and maintain a variable answer equal to 1 initially for each I multiply answer by j minus I plus 1. Okay, this is the problem. So to find this j, we'll just use our stack algorithm, the same we use for rectangle. So I'll just code that in. I'm just taking input right now. But don't we need to calculate for all j less than ai? Yeah, that's right. So I've not all j less than ai, j greater than I, where aj is less than ai. I mentioned that here on line 11. Okay, so Chaitanya, the problem is basically this. Um, so all the chefs are standing in a line, okay, where index 0 denotes the back of the line and index n denotes the front of the line. Now each chef has to pay his bills, but the chef, each chef, so in the array, ARRI denotes the seniority level of the chef, which is just an arbitrary value. Okay. Now each chef will give his work to the first chef in front of him who is junior to him, meaning ARRJ is less than ARRI. Okay, is that clear so far? Okay, I'll assume it's clear. Then, so the chaos caused by each such action, so the chaos caused by this is equal to j minus I plus 1. Now, what we need to output is the product of chaos across all chefs. Does that make sense? No, Siddhant, the chefs are not arranged in decreasing order of seniority. That's the challenge. So for each chef, they're arranged in a random order. Yeah, the chefs are arranged in a random order, Siddhant, and we just need to find the first chef that is junior to the chef that we're currently on. Please explain the constraints. The constraints are less than 100,000 for everything. So, what's K? Okay, the K is the different seniority levels. So basically, N, the number of chef, Siddhant Singh. So we need to find the order, basically the sorted order. Siddhant, you can unmute yourself for a second if you want. I'm not quite understanding what you're saying. Siddhant, you there? Siddhant, that's not exactly what we need to do. So I'll write it here. See line 24, Siddhant. For each I, we need to okay, we need to find the first index j such that uh, chef at j is junior to chef at I, and j is greater than I. Okay. So I'll let me just give you an example for this. So in an array 492741, okay, no, double 31. So for 4, the, it'll be 2, right? Because 2 is the first chef that's junior to him. Then for 9 it'll also be 2. For 2 it'll be 1. For 7 it'll be 3, and for 3 it'll be 1. And for 1 doesn't exist. No, Sachin, that's not what the function of the stack is. I had just explained this algorithm for rectangles, so I don't want to repeat it. But I've put a link above, a Geeks for Geeks link, which explains that algorithm. You can just scroll up in the chat, it's right here. Okay. So I'll just solve it right now. Int answer is equal to 1. So stack pair int st. Okay. While st is not empty, and then stack dot top dot first is greater than what we're trying to insert, strictly greater than what we're trying to insert. Then where int element is equal to stack dot top. Okay, the chaos caused by it is equal to element dot second. Okay, I minus element dot second plus 1. Okay, and so we need to multiply answer by the chaos, and then answer has to be modulo 1e9 plus 7. Okay, and stack dot pop. That's it. We can output the answer. Oh, I'm sorry. No test case format for this. That's not right. Okay. Okay, I didn't insert. You guys can write in the chat if you're having problem following the code I'll explain. Fortress. Okay, then I is 1. So we're at 2. Element of that's not right. It shouldn't have come. Can we solve it without using stack? Um, I mean, basically, instead of using a stack, we can use it, do an array or something. But even in the array, we'll just be sort of simulating the effect of a stack only. So stack is just the simplest way of doing it. But technically, in an array, also, if you know how to implement a stack in an array, you can just do it like that. But the basic functionality will be of a um, last and first out data structure only. Mm, okay, silly mistake of mine. Yeah, got it. Was this problem? Was the solution of this problem clear for everyone? Yeah, got correct answer. Palvi, do you think we should do another one, or do you think we should end it here?
Ask the audience need to be interactive here and share your thoughts in the comments. You can
Okay.
ask any generic questions. The participants can also ask any generic questions if they have.
Yeah. Guys, you can feel free to ask any questions relating to, I mean, linear data structures, even programming in general. If you guys have any doubts, go ahead. What kind of problems do we have in case the numbers we want to manipulate or obtain are very large? But begin to. Okay, so I haven't really used many big integer type data structures in C++. Um, Generally, most problems have like a modulo rule. So, like for calculating most large numbers, problems will usually just tell you to calculate in modulo 199 plus 7. And there are math tricks to do that for most operations. But no, for factorial and stuff, I don't know how to do in C++. So I usually use Java if I need to use big integer. Also, Rakesh, like for things like addition, multiplication, and stuff. I'm sorry, what did I say? Okay, so I said that for if I absolutely need to use like big numbers, then I usually just use Java because big integer is much simpler to use than defining it yourself. But otherwise, 99% of problems will have some trick where you can either use modulo, like you can either use modulo to make the number smaller, or you can use some other math tricks to break it down. There are actually very few problems that will make you use big integer because that's very biased towards programming languages. So very rare problems. But for those problems, I usually use Java because of simplicity. Is that fine? Okay. Do you guys want to do another problem? I'll open the polling if you want to do another problem. Okay, I've relaunched the poll. You can vote on the problem if you want. Or if you don't want to do a problem, you guys can also write in the chat if you guys want to discuss like something about programming in general, some doubt you have, I can help. Doubt in first question meaning rectangle, Sachin? Okay, you can tell. I'll message you my number. I don't want to repeat it for everyone, so you can message me after this. Uh,
Also, I think there are not many people who are active right now. I only see like
yeah, they're like
4
5.
votes.
Yeah.
Yeah. So maybe we can take this up offline. They can ask their doubts on discuss, and when we can discuss, take it up there.
Yeah.
Can-
Or I'll also just put my number here, so if anybody wants to discuss, you can message me.
Yeah.
Okay. I'll put my number in the chat, so if anybody ever has a doubt on programming in general, you can message me for help. So yeah, I think we can wrap the session here. Everybody, you can give your feedback in the feedback link so we can work on it and improve the session in the future. Okay. Thanks.
Okay. Thank you everyone for attending. Thank you, Arjun, for taking out time.
Thank you. No problem.